Welcome to the DIY Honda Garage channel. In this presentation, we will discuss DTC P24BF and its relation to the Honda CRV model from 2017 to 2022. The DTC P24BF indicates a specific issue with the Canister Change Over Valve control circuit, which essentially means there is a high voltage detected in the control circuit. This problem is vital to address because it is associated with the vehicle's evaporative emission system, ensuring harmful gases from the fuel system don't escape into the atmosphere. The evaporative emission system includes components like the evap leak check module and the powertrain control module, PCM. Locating and diagnosing the specific fault is key to maintaining the vehicle's environmental standards and performance. In the following slides, we will delve deeper into understanding this DTC and the necessary troubleshooting steps to resolve it. DTC P24BF indicates an issue with the Canister Change Over Valve, CCV, which plays a crucial role in the vehicle's evaporative emissions system. This valve controls fuel vapors from the fuel tank, directing them to either the canister to be stored or to the engine for combustion. The CCV is typically located within the evap system, which includes the evap leak check module and the PCM. The failure of this valve can lead to increased emissions and poor fuel economy if not addressed promptly. A high voltage condition might suggest there is a short or specific electrical fault that needs further investigation. You may observe this error affecting engine performance. Thus, it is critical to address this fault immediately to ensure compliance with environmental standards and optimal vehicle functionality. When diagnosing DTC P24BF, several potential causes emerge. The first possibility is an electrical short circuit within the CCV wire, which can lead to excessive voltage being detected. This usually occurs between the PCM and the evap leak check module, creating an unstable electrical environment. Another possible cause is a defective evap leak check module itself. If this module is malfunctioning, it may not accurately respond to the signals it receives, thereby triggering the DTC. Additionally, if the PCM is malfunctioning or has corrupted internal parameters, it may generate erroneous signals interpreting high voltage situations where there should be none. Each of these causes requires thorough testing to pinpoint the exact source of the problem and effectively resolve the DTC. Symptoms associated with DTC P24BF are critical indicators that something is amiss within the vehicle's evap system. One of the most noticeable signs is the illumination of the check engine light, which alerts the driver that an issue needs to be inspected. Additionally, drivers may experience poor fuel economy, as a malfunctioning evap system can lead to inefficient fuel usage. Another serious symptom is increased emissions, which poses a risk of failing emissions testing if the vehicle is subjected to it. These symptoms underline the importance of addressing the DTC promptly, as they can relate to both vehicle performance and environmental compliance. The first troubleshooting step involves verifying the problem using the Honda Diagnostic System, HDS. Start by turning the vehicle to the on mode, which powers up the system without starting the engine. Next, use the HDS to clear the existing DTC. This process can help refresh the system and provide a clean slate for retesting. Once the DTC is cleared, turn the vehicle to the off position, followed by turning it back to on again. Next, select the evap test, also called the evaporative leak check module test, from the inspection menu on the HDS. This test assesses the function of the evap system. If this test passes, it may indicate an intermittent failure, and you should check the connections at the evap leak check module and PCM for any loose or poor connections that may have caused the fault. If the evap test does not yield satisfactory results, the next step involves checking for shorted wires, specifically in the CCV line that connects to power. Begin by turning the vehicle to the off mode to ensure safety during the electrical check. Use the HDS to jump the SCS line, which stands for the Service Check System, and wait for over 1 minute. This prepares the system for diagnosing short circuits. After this, disconnect the PCM connector A, 50P, and the EVAP leak check module 8P connector. With these connectors removed, turn the vehicle to the on mode. The final step of this troubleshooting phase requires measuring the voltage between designated test points, ensuring that the PCM connector A, 50P, the mains disconnected. By measuring the voltage from test point 1 at PCM number 6 to the body ground at test point 2, technicians can determine if battery voltage is present. If voltage is detected, it indicates a short in the CCV wire, demanding repairs to restore proper conditions. In the third troubleshooting step, the focus shifts to evaluating the functionality of the EVAP leak check module itself. Begin by substituting it with a known good component to determine if the issue lies within the original module. It is crucial to ensure all connectors are securely reconnected before proceeding further. Following connector reconnection, exit the SCS mode using the HDS, which prepares the system for a new diagnostic run. Once in the correct mode, turn the vehicle to the on position again and perform a reset of the PCM using the HDS. This will help recalibrate the system parameters to eliminate any erroneous data. Subsequently, conduct the EVAP test, ELCM, again. If the test still results in failure, it indicates that the original issue persists. At this point, consult authorized service information for further guidance, or consider substituting the PCM if the conditions warrant such a drastic measure. After completing the diagnostics and repairs, it is essential to perform a final verification to ensure all issues related to DTC P24BF are resolved. Ensure that recent tests for the EVAP system yield pass results, indicating that the issues have been addressed effectively. During the verification process, also check that all connections related to the EVAP leak check module and PCM are secure, as loose connections could lead to a recurrence of the DTC. Finally, recheck the overall performance of the vehicle to ensure that it operates within expected parameters. This comprehensive verification step not only confirms the success of the repairs, but also ensures vehicle compliance and reliability in the long term. Preventive maintenance measures can significantly reduce the likelihood of DTC P24BF appearing in the future. One effective strategy is to regularly inspect the EVAP system, checking for wear, damage, or signs of carbon buildup, which could potentially affect the proper functioning of components. Additionally, ensuring that all connections, particularly at the EVAP leak check module and PCM, are tight and secure, can prevent intermittent faults from developing. Another vital aspect is the use of quality parts when replacements are necessary. OEM parts ensure compatibility and reliability, thus maintaining system integrity. By adopting these preventive steps, vehicle owners can enhance the longevity of EVAP system components, thereby minimizing future troubleshooting needs. In conclusion, DTC P24BF poses a significant issue related to the canister changeover valve and the overall functionality of the evaporative emission system. Addressing this code requires a careful and systematic approach, following the outlined troubleshooting steps to diagnose and repair the issue effectively. The symptoms associated with this DTC reveal immediate impacts on vehicle performance, including potential environmental consequences. Regular maintenance checks and preventive actions are essential for minimizing the future occurrence of this DTC. By prioritizing these strategies, technicians and vehicle owners can ensure the optimal functionality and reliability of the Honda CRV models between 2017 and 2022. Please like and subscribe to the channel. See you next time.